Hello everyone, this is Dr. Surya. So today we are going to see about activated sludge process and a problem on your activated sludge process. Okay, so what is this activated sludge process? It is a type of biological wastewater treatment process to treat our sewage using the aeration as well as a biological floc which is composed of bacteria as well as your protozoa. So I am going to explain you with this. So first initially you will be getting your inflow. So let Q be the inflow. Okay, so this inflow will have a BOD of Y0. So imagine that Y0 is going to be a BOD. Now when the inflow is coming, initially it will taken into a aerator tank. Okay, so this aerator tank, in that you will be having a certain volume will be there, and XT is going to be the concentration of MLSS. MLSS is your mixed liquid suspended solids, and here you will be having your YSBOD. Okay, so initially you are having your Q as the inflow. Now and after this process it will going to your secondary clarifier, that is your secondary sedimentation tank. After that the remaining will go as an effluent. So this is how it is going on, the process is going on. So when it comes to your secondary effluent or whatever it is, so here when it is going outside, certain amount of BOD will be removed, that we take it as YE. YE is going to be the BOD of the effluent that is coming out. Okay, and XE be the concentration of solids in effluent. Okay, so how much concentration of the solids is there in effluent. Okay, now when it come back to here, some sludge will be wasted. So let us take this to be QW. QW will be the wasted sludge. So what is the amount of sludge that is wasted? That we call it as our QW. Next, XR be the concentration of this particular concentration of solids in wasted sludge. Okay, so if you want to enhance the microbial activity, certain amount of sludge has to be taken and returned back into the aeration tank, so that to enhance your microbial activity. So microorganisms will grow and it will oxidize the organic matter. So imagine that some sludge has been taken and again it is circulated into your aerator tank. So take that QR to be your returned sludge. Some around 30 to 40% will be returned. Okay, returned sludge. Okay, let XR be the concentration of solids in returned sludge. So let this be returned activated sludge. So I will write it as RAS. Let this be WAS, that is wasted activated sludge. Okay, when you come here, initially you will be having that returned activated sludge is going and again it is coming. So initial inflow is going to be Q. And you are adding your returned sludge also. So here you will be having Q plus QR. So return activated sludge is having. Again you will be having your mixed concentration will be there. So X be the MLSS one, mixed liquid suspended solids. When you come here, you will be having your wasted sludge, you have to minus it off. So BOD minus your QW, because QW has been wasted it off. Okay, this is how the process will be repeatedly going on. So in simple I can say that this is a biological wastewater treatment. So microorganisms will be consuming organic matter from the wastewater and they will be using their oxygen for their respiration, and again the process will be repeated. So okay, the main purpose is that we have to oxidize all the biological carbonaceous biological matter and nitrogenous matter, mainly ammonia as well as our nitrogen biological matter, and we have to remove of the nutrients. So this is how the process is going to take place. Okay, so the main aim is we have to remove, you have to oxidize and remove the finely divided suspended materials which has not been removed in the earlier treatment, that is in the primary treatment. If anything is not removed, that we have to remove it out. Okay, so it will be complete, this process will be having a full of organism, and that is going to be responsible for the decomposition of the waste. So they use waste as food and an energy source for its survival as well as its reproduction, and this is how it is going on. Okay, so and these microorganisms, that is, we have to keep in mind that these microorganisms will take the biological solids. So whatever thing is there, it will take that solids for its growth and it will do off. Okay, so primary effluent plus return sludge is called as your MLSS, mixed liquid suspended solid. So primary effluent is there as well as your return sludge. So return sludge is repeatedly it is going on and it is mixing in the aerator tank. That's why your MLS is forming, since because it is mixing it up. Okay, so this is a basic concept. So this is how your activated sludge process is working on. So there are two kinds of growth. Film growth is there. One is going to be the attached growth and another one is suspended growth. So this attached growth is called as fixed film. So this system will include your trickling filter, your bio towers as well as rotating biological contractors, where your biomass will be growing on a media and then sewage will be passing over the surface. So in attached, the biomass will be attached to the media itself. So in that media your sewage will be passing. Suspended growth means biomass will be mixed with the sewage. Okay, and it can be operated in a very small space. So this activated sludge process is going to be a suspended growth. So where your biomass is again it is mixed with the sewage and it is acting on. Okay, now we'll proceed to the problem. So we have an average operating data for conventional activated sludge is given. They have given wastewater flow, volume of aeration, what is the influent BOD, effluent BOD, MLSS, effluent suspended solids, waste sludge suspended solids, quantity of sludge, and they have asked us to determine the aeration period, F/m ratio, percentage efficiency of that, how much percentage has been BOD has been removed, and finally we have to determine the sludge age. So first we will go one by one. So first one is going to be our aeration period. So what is this aeration period? Aeration period is nothing but your hydraulic retention time. Okay, HRT, we call this as HRT. HRT means the time that the wastewater or sludge is present in the digester. That is going to be called as your HRT, how much time it will be. Okay, so if you have one more retention time, that is going to be a solid retention time. So that is how much average time that the bacteria is in the digester. Bacteria or solids is in the digester, we call it as solid retention time. And HRT is the time, how much time the wastewater or sludge is present in the digester. So that is going to be a HRT. Okay, how you have to determine it actually? It's going to be very simple. T is equal to V by Q. Okay, so V is nothing but your what is the volume of the tank given to you divided by the rate of sewage. So what is the volume of tank given to us? It is going to be 10,900 divided by 35,000. Volume is given, the Q is given as 35,000. Only thing is that we have to note that they have given the aeration period. If you do this time, it is going to be for number of days. So I have to give the time aeration period in hours. So day to hour, the conversion is that you have to multiply by 24. So this is for your day to hour. So when you do it off, you will be getting as 7.47 hour. Okay, second one. So we have determined our aeration period. F/m ratio. What is F/m ratio? F/m ratio is your food to microorganism ratio. So what is food here? Food is nothing but your mass of BOD applied. So how much BOD is applied to the aeration system? So mass of BOD that is applied to aeration system is going to be called as your food. So F is nothing but your Q by Y naught. Okay, so what is Q? Q is given to you as 35,000. That is how much wastewater flow is there. So that is 35,000. And what is Y naught? Y naught is nothing but the influent BOD. How much BOD we are giving it inside. So which is 35,000 into 250. One thing you have to note that this 35,000 is in meter cube and this 250 is in milligram per liter. So what I am going to do is that I am going to convert this meter cube into liters. So in order to convert meter cube into liters, so I am multiplying this by 1000. Okay, so this 1000 is for meter cube to liters. Okay, so into 250. Okay, so if I do this, I'll be getting the answers in milligram, because you are having a milligram here, so the entire answer will be in milligram. But in the problem, they have asked me to determine the answer in kg BOD. So I have to convert this into kg. So in order to convert this into kg, I have to divide this by 10 power 6. So this 10 power 6 for milligram to kilogram. Okay, so when I do this, I will be getting my F value as 8750 kg per day. Hope you understand. Again I repeat, 35,000 is in meter cube, 250 is in milligram per liter. So here your conversion is liter. So what I am doing, I am converting this meter cube into liters. So if I multiply by 1000, this will be converted into liters. So into 1000 into 250. So this answer, this entire answer I will be getting in milligram. So in the problem I have asked us to determine in kilogram. So I am converting milligram to kilogram. So that's why I am dividing it by 10 power 6. Okay, so I am getting my F value as 8750 kilogram per day. Now I have to calculate by M value. So M is microorganism value. So that is nothing but mass of my MLSS, mixed liquid suspended solids. So which is going to be V into XT. Okay, so what is XT? XT is nothing but the concentration of MLSS. So concentration of MLSS is given to me in the problem as 2500. Okay, they have given the value as MLSS, that is 2500. So V value is nothing but my volume of the aeration tank. Again, this is in meter cube. So I am converting it into liters, that is into 10,000. MLSS value is given in milligram per liter, that is 2500. So if I am multiplying this, I will be getting the answer in milligram. So in order to convert this into kilogram, I am dividing it by 10 power 6. Okay, so I will be getting my M value as 27250 kilogram. So what is asked us? We have to determine our F by M ratio. So F by M is we have determined separately. So that is 8750 divided by 27250, which gives me 0.32 kg BOD per day per kg of MLSS. Finish. Now we'll move on to the third point. So what is our third point? We have to determine the percentage efficiency of BOD removal. That is how many percentage the activated sludge has removed the BOD. So which is going to be very simple. That is how much BOD is coming inside the plant, that is incoming BOD minus outgoing BOD divided by incoming BOD into 100. That gives my percentage value, percentage of my BOD removal. Okay, so here in the problem, the incoming BOD, that is my influent BOD is given as 250, and the effluent BOD, that is the outgoing BOD, that is 20 divided by 250. Okay, into 100. So the efficiency is going to be 92%. This is also over. So next is that we are going to get our final one, that is my sludge age, which is your theta C. Okay, so what is the sludge age first of all? So it is the measure of the length of the time a particle has been undergoing, a particle of suspended solids has been undergoing aeration. So how much time, this is length of the time the particle is going to undergo your aeration process. That is going to be called as your sludge age. Okay, this indicates this is going to be the residence time of the biological solids in the system. Okay, so now we are going to calculate this. So the formula for the sludge age is given as Vxt divided by QWXR plus Q minus QW into XC. Okay, so this is what is given. So simple, I can say that mass of suspended solids in the system divided by mass of solids leaving the system per day. Okay, so mass of suspended solids is nothing but we have calculated already, that is V into xt, that is going to be the mass of suspended solids. Okay, so how much it is removed, we are going to calculate in this manner. Okay, now V into xt, already we have calculated this in the previous one. So if you see here, V into xt is calculated already, so that is 27250. So I am taking the same value here, 27250 divided by, okay, so what is my QW value? QW value is your waste sludge, quantity of the waste sludge, so that is 220. What is XR here? XR is going to be the waste sludge suspended solids. So it is given in the problem as 9700. Again, if you see, your waste quantity of waste sludge is given in meter cube and your waste suspended solids is given in milligram per liter. So what I am doing, again I am converting this meter cube into liters. So I am putting 1 into 1000 here. Okay, divided by, since because this unit is in kilogram, so the coming answer will be in milligram. So I have to divide this answer by 10 power 6. Keep that, the unit conversion is most important. Plus, okay, so what is your Q value here? Again, your Q value is given as 35,000. Okay, minus waste sludge value. Waste sludge value is given as your effluent, which is given as quantity of waste sludge given as 220, that is 220. Okay, and if you see here, you are having your XE value. So XE value is going to be 30 milligram per liter. Again, this unit is in meter cube, this is in milligram. So I am converting this into liters, that is into 10,000, divided by the whole answer I will be getting in milligram, and I am converting this into kilogram into 10 power 6. So as simple as that. So this 10 power 6 I can take into the numerator, that is 27250 into 10 power 6 divided by 220 into 9700 into 1000 plus 35,000 minus 220 into 30 into 1000. Okay, so if you do this, I'll be getting the answer of 8.58 days. So my theta C value is 8.58 days. So this is the answer. And I have for other videos, the playlist has been provided in the description for other subjects. Kindly do watch. I hope you have understood the problem. Happy learning and thank you.